You're watching a Channel 98 NBISD TV production.
Welcome out there in TV land to Deja Vu. It's Algebra 2. As always, I'm your host, Kevin Corpy, bringing you today 30 minutes full of nothing else but good, quality, wholesome, fun mathematics. And today you're in luck because we're going to be talking about rational expressions. Last week we did talk about rational expressions, but we just multiplied and divide. Kind of boring. Today we're going to be adding and subtracting, which I guarantee is going to be much more exciting because it's a little bit more challenging. So, if you're interested in Lesson 22, download the worksheets from the district website, sharpen your pencil, stick around for a while, and learn something. All right, Lesson 22, a dandy. And of course, we've got the rational expressions again, same as last week. Last week we multiplied, we divided, and we remember that dividing is the same as multiplying by the reciprocal, right? You reciprocate the second factor, not the first. Well, today we're going to be adding and subtracting rational expressions. Then we're going to be looking at complex or compound fractions, which sounds very enticing, I know. Well, before we start talking about rational expressions that have variables in them, we need to review a little bit about how to add rational numbers, that is fractions. So let's look at something right here. I'll zoom in so you can see a little bit better there at home. Don't get off the couch and walk toward the TV. I'll come to you. What if I have like 3/7 plus 2/7? Okay? I have 3/7 a fraction plus 2/7 a fraction. Can I add those? Well, I actually can. 3 plus 2 is 5. Do we add the bottom? Is it 7 plus 7? Is it 5/14? Well, actually, it's not. If we were multiplying these, we multiply straight across. 3 times 2, 7 times 7. But when we're adding, we need a common denominator. And in this case, the common denominator is 7. So think of these as parts. We have 3 parts out of 7. And we're adding 2 more parts out of 7. That leaves us with 5 parts still out of 7. We don't quite have the full whole of 7. Okay, we need 2 more 7s to make the whole. So when we're adding fractions or rational expressions, we need a common denominator. Then we'll add the numerators, and then we take the common denominator that was in the denominator of each one to begin with as the same denominator in the final answer. Okay, you got it? Now what if we don't have a common denominator, like this problem here? I have 3/2 plus 7/3 minus 1/6. Well, I need to find a common denominator. It can be any common denominator. But ideally, to make the mathematics a little bit easier to work with in the end, we're looking for the least common denominator. That is the least common multiple, or the LCM for least common multiple. And because the multiple we're looking for is in the denominator, it's sometimes called the LCD. But it's the smallest number that each of our 3 denominators will go into evenly. Okay? So we have a 2 and a 3 and a 6. Well, what are the factors of 2? The factors of 2, or I'm sorry, the multiples of 2 are 2, 4, and then we can keep going. 2, 4, 6, 8. Who do we appreciate? Our math teachers, right? Okay. What are the multiples of 3? I got 3, 6, 9, so on and so forth. And what are the multiples of 6? Well, I have 6, 12, 18, so on and so forth. Now you're looking for the smallest number that occurs in each of the 3 sets, and that number is in fact 6. So 6 is the least common multiple. 2 goes into 6 3 times, 3 goes into 6 twice, and 6 goes into itself once. Okay, so what do we do once we have that least common multiple? Well, we need to make all of these in terms of 6. So the 3/2 will get this. Now in mathematics, we can multiply by an expression so long as it's equal to 1. It's the identity element, remember? And so I need to multiply this 2 by 3 to get it to be a 6. Well, I have to multiply by 3 over 3 now. That's a clever form of 1. I do the same thing with the 7/3. It already has the 3. It needs a 2 factor to become a 6. So I multiply by 2 over 2. And then the 1 over 6 is already good. So notice I have 2 times 3 plus 2 times 3 minus 2 times 3. They're all 6. So now that I have that, I can multiply everything out. When we multiply straight across. So I get 9/6 plus 14/6 minus 1/6. And now since I have a common denominator, I can write those all in terms of one fraction, 9 plus 14 minus 1 all over 6. and that gives me 22/6. Now that's an answer, but 22/6 simplifies. There's a factor of 2 in there, so we want to simplify it. We divide a 2 out and we get 11/3, and 11/3 is the answer, and it's in simplified form. Okay, so we know the process for adding numbers. It's the same process when we're adding rational expressions with variables. So let's look at this expression. I have 3 terms, and each of the terms are rational. They're fractions. I have an x plus 1, an x minus 1, and an x squared minus 1. Since we're looking for the smallest multiple of each of the factors in the denominator, one thing that we could do is to try to factor the denominator completely. And if we do that, we'll get 2 over x plus 1. That's already factored. X over x minus 1 minus x squared over. Now x squared minus 1 is a difference of 2 perfect squares. It factors into x minus 1 times x plus 1. So here's the easiest way to find the least common multiple when you don't have numbers. Let's go to the first term. The first term has an x plus 1 in the denominator. So the LCM is going to require at least one factor of an x plus 1. We need one for sure. We have an x minus 1 factor. Oh, that's not x plus 1, so we're going to need an x minus 1 factor as well, at the bare minimum. This one here has the product x minus 1 times x plus 1. So we're going to need one of those. But look, we already have one of each of those. So this right here is going to be my LCM, or in this case, my LCD. So now we have to multiply each fraction that doesn't already have the denominator, the least common denominator. We need to multiply them by clever forms of 1 so that they obtain it. So here we go. We have 2 over x plus 1, and I need to get the x minus 1 factor to it, so I need to multiply by x minus 1 over x minus 1. Plus x over x minus 1, the next term. It has the x minus 1, it needs the x plus 1. But I need to multiply by 1, so I'm not really changing anything. And then the final term is good. It already has both of the factors that I need. So notice your denominators, if you multiply them all out, will give you x plus 1 times x minus 1, which remember is x squared minus 1. So now here's an important step. I have 2 times the quantity x minus 1. I need to distribute the 2 in the numerator. That's going to be 2x minus 2. And then I have plus x times x is x squared, plus x times 1 is x. Again, I have to distribute the x to both of those. And then I have minus x squared. Now here's a little time-saving tip. You know at this point you're going to have a common denominator. So instead of writing 3 individual terms, each over the common denominator, just combine your numerators directly after you carefully distribute and put them all over one common denominator. Okay? And now what we need to do is we need to combine like terms in the numerator. And it's good to start with your largest powers of x. So I have an x squared minus x squared. Nice. In this case, they cancel. We don't have any x squareds left. Then I have a 2x plus 1x. That's a 3x. And then I have a minus 2. All over x plus 1 times x minus 1. Now, there's no common factors that can divide out, so we can't simplify anymore in this problem like we could up here with 22 sixes. But depending on what your teacher wants, you can leave it in this factored form, or you can actually expand out the bottom to get x squared minus 1 again, and either form would be correct. Again, it's just depending on what your teacher likes. I'm going to go ahead and leave mine in expanded form. Now, recalling from last week, when we have rational expressions, we have variables in the denominator, which means we potentially can be dividing by 0, and we don't want to do that. So let's go back up to the original expression, not the end, the original expression, and see which values of x are not permissible. Well, those are the values that make the denominator 0. A negative 1 plugged in here gives me a 0, so I can't use negative 1. A positive 1 here gives me a 0 in the denominator, so I can't use it. And remember, this was just the combination of both factors. So in this one, negative 1 or negative 1 don't work. But any number that doesn't work in any of the terms will not work in the entire expression. So once we get our final simplified expression down here, we will go ahead and say now, comma, x shall not, cannot equal plus or minus 1. That's a nice way to say it. And if you box that final answer, that's a good way to present the entire solution. Okay, another example, same technique, different problem. Now notice this one kind of looks funny. You've got some exponents that are negative. Well, we know how to handle negative exponents. Remember, all you have to do to get rid of a negative exponent is to bring the entire factor to the other side of the fraction, from the numerator to the denominator, vice versa, and change the sign of the exponent. So in this case, I'll put it all over 1. Now it looks more like a fraction. So your first step is to get rid of the negative exponents. Well, here's a common mistake. Most people want to bring the 3 down to the denominator with it as well. but it's 3 to the positive first. He's okay. Times x minus y quantity to the negative first. So that becomes 3 over x minus y all to the first power, which we don't need to write the parentheses. So don't bring the 3 down there. It's 3 to the positive first. Minus, now I have to bring the x plus y down to the bottom, and the 2 is already down there waiting to greet him with open arms. And it's to the positive first. But I need parentheses here because it's multiplied by the 2. I don't really need them there. Now, I need to list the factors of each term of the denominator. So the LCM, it requires an x minus y. This term requires a 2 and an x plus y. So guess what? The LCM is the product of all three of them. And so I'll go ahead and go through like I have been. I have the x minus y, so I need the other 2. I need the 2 times the x plus y on this term, multiplying by it over itself. And then I have minus 1 over 2 x plus y, and it just needs the other guy, x minus y over x minus y. Routine process, multiply by 2 fractions equivalent to 1, so that when you're done in the denominator, each term has the same denominator, a common denominator. And in this case, it is the least. So now what we'll do is we'll multiply the numerators. So I get 6x plus 6y. And again, when we're subtracting a binomial, we need to be very careful and distribute the negative or the negative 1 to each term. So it's a negative 1 times x, which is minus x, and a negative 1 times negative y, which is a positive y. Very careful. Common error for students to make right there is not to distribute the negative, to call that negative x minus y. Okay? And in the bottom, I'll have 2 times x minus y times x plus y. And now all we have to do is simplify the numerator. I have a 6x minus x, so that's going to be a 5x. And I have a 6y plus y, which is a 7y. And all of that's over this expanded, I'm sorry, not expanded, factored. It's a factored version in the denominator. So again, depending on what your teacher wants, she might want you to expand the bottom by distributing everything. But this is good. Now, what can x not equal? Well, in the beginning I had an x minus y. So this one's a little bit different. I know that x minus y, the denominator, cannot equal 0. Well, if I solve for x, that means x cannot equal y. It means x and y cannot be the same number. This one has an x plus y in the denominator. So I also know that x plus y cannot equal 0. And if I solve for x, I know that x cannot be the opposite of y. So those are the two values of x that are not allowed. X cannot equal plus or minus y. X can't be the same as y, nor can it be the exact opposite. But as long as they're different magnitudes, it'll work. All right? There is the simplified expression. We're going to take a real quick break. Don't go anywhere. And while you're sitting there watching these public service announcements, think about this question. What do you call a pig who gets all of his answers wrong on a math test? The answer, when we get back.
I remember how much you said you liked wine.
Oh.
You don't have to be perfect to be a perfect parent. There are thousands of teens in foster care who would love to put up with you.
When you give up the ability to decide for yourself, you give up what makes you, you.
Welcome back to Deja Vu. It's Algebra 2. I'm your host, Kevin Corpy, talking to you today about rational expressions and complex fractions. We're going to add them and subtract them. We got a nice example at the end of the show, but we're not quite there yet. Did you think about what do you call a pig who gets all his answers wrong on a math test? What do you call him? Well, you call him mistaken bacon. Back to math. Now we are going to take a look at something called a complex or a compound fraction. Not fracture. Ow, that's something entirely different, and I know that all too well. A complex or a compound fraction is nothing more than a fraction within another fraction. Okay? So we consider complex fractions to not be in simplified form. So what we want to do is we want to eliminate the complex fraction. There's a couple of ways to do it. I'm going to show you both ways once, And then I'm going to show you the other way for the rest of the time because it's more efficient. And I would encourage you to try to be more efficient if you're effective already. So here we go. Notice that in this thing right here, we have 1 plus 2 over x. So there's a fraction, 2 over x, all divided by 5x minus 2. And that's what the fraction means. It means divided by. So I have a fraction divided by something. It's a fraction within a fraction. That's complex. Now, there are two ways to do this. Method 1 is going to be basically doing what we did last time. We're dividing by something, and remember, dividing by something is the same as multiplying by the reciprocal. I'm going to go ahead and make 5x minus 2 a fraction by putting it over 1. So now I have this numerator, which is a fraction, divided by the denominator, which is also a fraction. We can write that like this, 1 plus 2 over x divided by 5x minus 2 over 1. Now, this is just a little trivia. That division symbol right there is called the vinculum, V-I-N-C-U-L-U-M, vinculum, okay? If you're ever on a millionaire game show or something. Now, dividing by fractions is the same as multiplying by the reciprocal. So from there, I'll get 1 plus 2 over x, and I'll times or multiply by the reciprocal of the second factor. There we go. Now, in order to multiply these, I need to have a single fraction times a single fraction, which means I need to get 1 plus 2 over x together. I need a common denominator, and it's going to be x. So I'm going to have x over x, which is equivalent to 1, plus 2 over x. So I get x plus 2 over x times 1 over 5x minus 2. So that's getting a common denominator like we just did. Now, since they're multiplied, I can multiply straight across. So I get x plus 2 times 1, which is x plus 2, all over x times 5x minus 2. And that would be a factored version, or if you needed to expand it, this one's real easy, it would be 5x squared minus 2x. So either one of those would work. Now, what values of x can we not use? What's in the denominator? Well, x cannot equal 0 because that's the denominator of this fraction. And 5x minus 2, remember, was in the denominator of the whole fraction. And so x cannot equal 2/5, which is the value that makes that 0. And there you go. And notice it reappeared right here, 5x minus 2. So there's simplifying a complex fraction. Method 1. Method 1. A little bit labor intensive, but it works. It's effective. Now here's another method. Method 2 involves the LCM every time. And what it involves is multiplying the entire fraction by the LCM over the LCM, which remember is equal to 1. So here's what we need to do. We go through and we make fractions out of everything. And now we go through in the numerator, which is up here, and in the denominator. And this may sound tricky, but we look in the denominators in both the numerator and the denominator, which remember, this is a complex fraction. So up in the numerator, in the top half, think about it as one problem. I have an x. So that's one of the denominator factors. In the denominator, as another separate problem, I have a factor of 1. So what's the least common multiple between 1 and x? Well, it's x. And so what I can do is take my original problem, 5x minus 2, and I'll put it over 1 again, and I'll multiply the whole thing by x, 1 in the numerator, over x, which is my LCM over the LCM. And now what I will do is I will distribute one of those x's to the numerator, and the other one will get distributed to the denominator. And look what happens. X times 1 is x, plus 2 over x times x, the x's divide out, leaving just 2. That's pretty cool. And at the bottom, since it's just over 1, I can distribute the x. I get 5x times x, which is 5x squared minus 2x. And notice right here, basically, in one step, I get the answer that I got way over here in multiple steps. So the LCM over the LCM is a very efficient method. And I would encourage you, first and foremost, to be effective. Pick a method that you're more comfortable with. But if you have some free time and you want to get better, then try to be efficient. Let's take a look at another one that has some funky negative exponents written in there and see, although this one doesn't look like it's a fraction within a fraction, that it is in fact a fraction within a fraction. If we go through and we carefully get rid of all the negative exponents, you'll see that. Now think of this as two problems. I have a numerator. 3 times x to the negative first, if I rewrote that as 3 divided by x to the positive first, minus y to the negative first is the same as 1 over y. That's my numerator. All of that is now over these two terms. Well, x to the negative first is 1 over x plus 2 times y to the negative first is 2 divided by y. And that term happens to be in the denominator. It's very important to know how to go from here to here. If you can't get from here to here, then the rest of the problem is not going to be correct because it's not equal to the original expression. Now, I have a numerator with two denominators, x and y. So the least common multiple up there is the product xy. In the denominator, I have two denominators, which is another xy. So the LCM of this is x times y. And so I'm going to use method 2. If I multiply it now by xy over xy, I can now carefully distribute. And notice I added the parentheses. It helps me see the two terms. And then in the denominator, I will do the same thing. I will distribute to each term. Drawing arrows is fine. So x times y times 3 over x. Well, these x's will divide out, and you're just left with 3 times y in the numerator minus 1 over y times xy. Don't let the bottom distract you. You have 1 over y times xy. Well, now the y's will divide out, and you're left with minus 1 times x, which is minus x. Now you're in the denominator, so think of it as a separate problem. Hey, twice the math in one problem? That's a bargain. We get xy times 1 over x. The x's are going to divide out, leaving 1 times y, or just y. And then 2 over y times xy. The y's will divide out, leaving 2 times x. Positive 2x. And believe it or not, you're essentially done. Now, if your teacher wants you to write your variables in alphabetical order, your x's would go first, and we'd call that negative x plus 3y and 2x plus y. But that's a preference thing. By the commutative property, they're equal. Now, in this case, we could go through and see what x and y cannot equal. Well, x and y are both in denominators, so if you needed to add that, you could say that x comma y, neither one of them can be 0. That gives me division by 0. Now it's time for my favorite part of the show.
Deja Review.
All right, today on Deja Review, we're going to take a little road trip. A little road trip because we're running out of time. All right, let's say that you're in New Braunfels and you're going to San Antonio. Maybe you're going shopping, okay? Well, let's say that you average 60 miles per hour on your trip to San Antonio, okay? It's under the speed limit. Remember, you have traffic lights and stop signs, and maybe you're going more than 60, but you average 60 miles per hour on the trip to San Antonio. But on the way back, because you're coming back and there's traffic from maybe people getting off work, you're only average 40 miles per hour on the exact same distance on the return trip. So you average 60 going over, you average 40 coming back. Here's the question. What was your average speed for the entire trip? Well, most people would say if you're going 60 miles on the way over plus 40 miles on the way back on average, then you divide those by 2 because you have two numbers you're adding. And that would give you 100 divided by 2, which would mean that your average speed on the entire trip was 50 miles per hour. And that's what most people might think intuitively. But guess what? That's actually incorrect. Now, this type of question is a very important question not only for your math class, but it's a nice question that's typically asked on the SAT, which is a reasoning test. It's called a weighted average. It's called a weighted average. It's a weighted average question. And I'm going to show you how to work them. Here's what we're going to do. We're going to define some variables. I'm going to let the little letter d equal the one-way trip distance. Okay, it's the distance we travel going to San Antonio. So what was our total distance that we traveled? Our total distance then, we traveled d twice. So it was 2 times little d. That was our total distance. Well, now what we need to do is we need to figure out how we can write our times for each trip. Well, there's a real important equation I call the DIRT equation. It's d equals RT. Distance is rate times time. Okay, drive 50 miles per hour. For 2 hours, you travel a distance of 100. It's a pretty basic equation. If I solve that for t, I get my distance, little d, I'm going to call it little d, divided by the rate, which is my speed. Okay, so now I need to figure out, if t is distance divided by rate, I need to figure out what my total time was. Well, my total time was a combination of the time it spent going to San Antonio and the time it spent coming back from San Antonio. So it's d divided by r. So the distance is the same both ways, but on the way over, my r was 60, plus coming back, my distance was the same, but my rate was, on average, only 40. So there's the total time. Now, I can use the distance equals rate times time to figure out what my rate is. That's what I'm interested in, my average rate. So now if I solve this equation for r, which is my rate, or my speed, I get r equals the distance total divided by the time total. If you take your total distance that you traveled over the entire trip both ways, divided by the total time, you will get your average for the total. So here we go. My rate, which is my average speed, is equal to the total distance, which remember was 2 little d, divided by the total time, which is d divided by 60 plus little d divided by 40. Hey, guess what? I just created a complex or a compound fraction. If I can simplify this compound complex fraction, you're going to see that it doesn't even matter what little d is. Okay? It could be for any distance so long as the averages are the same. I will find the least common multiple. So 60 and 40 have a least common multiple. Let's see, that's 60, 120, and then 40 is 40, 80, 120. So 120 is the least common multiple. So I'll multiply by 120 over 120 using method 2. If I distribute in the numerator, I get 120 times 2, which is 240 times little d. And in the denominator, when I distribute, look what happens. I have 120 divided by 60, which is 2. So it's 2 times d. And in the denominator, I have 120 divided by 40, which is 3 times d is 3d. Ooh, you got your glasses on at home? Well, let's see. If I combine, I get 240d divided by 5d. Now notice, this is nice because the d's, the distances that I traveled, will divide out. So I could have traveled 1,000,000 miles both ways and averaged the same speeds, or only 1 mile both ways and averaged the same speed. The distance is really irrelevant. And I get 240 divided by 5, which comes out to be 48 miles per hour. Whoa, 48 was your average speed. It wasn't 50. 50 is the halfway point between 40 and 60. Your average speed was less than the halfway point. And that should make sense to you now. And if it doesn't, let me explain why it should. You spent more time in the car traveling at the slower speed. So the average is going to be weighted towards the smaller speed. You spent less time traveling at the faster speed. And so the average will not be pulled towards that one. You spent less time doing that. And so it's like if you have multiple grades. If you have more grades in your class that are below 50 than you do grades that are above 50, your average will be unfortunately below 50. And hopefully it's much, much higher than that. But 48 is the weighted average, and we found it by setting up a complex fraction and simplifying it. We are, unfortunately, out of time on today's show. Covered a lot. We're going to cover a lot next week. Every week is full, 30 minutes from start to finish, full of math, trying to get a whole week into a 30-minute weekly program. So I hope you will join me next week for another episode of Deja Vu. It's Algebra 2. But until then, I am Kevin Corpy reminding you, of course, to do your homework.